Jai Bharat to all students. In last lecture, we have discussed about what is eigenvalue and eigenvector and how to find eigenvalue and its eigenvector in 2 by 2 matrix. Okay. So now in this lecture, we will discuss how to solve eigenvalue and eigenvector in 3 by 3 matrix. Okay. So let's first of all start with a quick revision of last lecture, how to find out eigenvalue and eigenvector and its equation. Then we will start with the example of the 3 by 3 matrix. Okay. For how definition of eigenvalue and eigenvector is, for given any matrix A, what are the vector x for which the product matrix and vector is a scalar multiple of vector? Okay, so we have to find about this vector ax is equal to lambda x, which is x is equal to lambda x. Lambda is a eigen value, or let's say scalar value. X is a eigen vector, it's related eigen vector. Okay, for some scalar lambda. Okay, so we have to find what is a lambda, then we will put this lambda in this equation. We have now matrix value of matrix A, lambda, so we can solve the we can find the vector, eigen vector. Okay, so now take left side ax minus lambda x. So if we want to common out x, last I have said that you cannot subtract with the matrix and scalar quantity and addition. Okay, this is not possible. This is a scalar quantity 1 2 3 4 anything, and this is a matrix 2 by 2 matrix, 3 by 2 matrix. Okay, so we cannot perform this operation addition and addition and subtraction is not possible with the scalar quantity. Okay, so now this value we have to transfer this into matrix. So how do we transfer? If we multiply with this as a identity matrix, same as a matrix. If it is a 2 by 2 matrix, then identity matrix is also 2 by 2. If it is a 3 by 3 matrix, then identity matrix is also 3 by 3 matrix. Okay, so we have multiply with identity matrix. So now we have this equation. Now we all know that if a into x is equal to 0, so if we want to find out x, what is the x, and it is an infinite solution, then determinant of a is always 0. Okay, so now this we have to find about this a minus lambda I determinant and compare this with 0, and then we can find lambda. Okay, case 1 and case 2, if determinant is c is equal to 0, then it's a inverse possible or not, like this ax is equal to 0, so which is have same as a like this. Here we have matrix as a minus lambda I. Okay, so determinant of a minus lambda I have to become 0, so that we can find the value of x. Okay, so after lambda we can find the value of x eigenvector. Okay, so now let's start with our 3 by 3 matrix. Okay, here this is 3 by 3 matrix. We have to find eigenvalue and eigenvector. Okay, now first we calculate a minus lambda I. Okay, here a minus lambda I is identity of 3 by 3 matrix. So we have now 2 minus lambda, 4 minus lambda, 3 minus lambda, and here 4 and 5 will remain same because this is 0. Okay, so this is our a minus lambda I. Now this determinant should equal to 0. So determinant of this 3 by 3 matrix is equal to 0. Okay, now we have to apply determinant. Okay, now you can see that here this row has maximum 0. Okay, so we will take as a first, and this is become 2 by 2 matrix. So 2 minus lambda in bracket. How to find 2 by 2 matrix? Determinant of 2 by 2 matrix, multiplication of diagonal element minus other diagonal element is equal to 0, because all are 0. So this one, only one element. Okay, now from this equation we have to find lambda. Okay, now let's say do not multiply with this direct lambda equation. So if we multiply, then we have say lambda cube. Okay, this lambda, this lambda, and this lambda. Okay, so we do not want multiplication, we only simplifying this equation. How? Okay, let's say this is a 1. If x into y is equal to 0, so we can say that either x is equal to 0, x is equal to 0 and y is equal to 0. So here this is x and this is all as a y, let's say. So we have now x 2 minus lambda is equal to 0. So one root will become lambda is equal to 2. One root will become 2. Now if let's say this is become, this is equal to 0. So 5 and 4 will multiply, change in the right side. So this is equal to 5 into 4. So with the help of quadratic equation we can solve root of lambda is equal to -1 and 8. You can solve in your book also. Let's say if we say this lambda minus 4, we can write like this, lambda minus 3, we common out minus minus. Okay, minus 20. Okay, solve this lambda square minus 7 lambda plus 12 and minus 20. Now this is become minus 8. So one root is -1 and one root is -8. Solve this, lambda square minus 7 lambda minus 8 is equal to 0. We can solve this linear equation and we get the lambda of -1 and 8. So here now in 3 by 3 matrix we have 3 value, -1, 2 and 8. So in 3 by 3 there are, for this matrix there have 3 eigenvalue, -1, 2 and 8. Okay, so now we have to find vector for this eigenvalue. You can you have to find all the eigenvector of these 3 different eigenvalue. Okay, so now let's say for we have find out about the first, we have calculate with the eigenvalue as a -1 and find eigenvector. Okay, so how do we find? Let's take our example a x is equal to lambda x. Okay, here a matrix, here x vector xyz, lambda is a -1 and xy vector xyz. Multiply with this we get 2x, 4x plus 5y and a 4y plus 3z. Okay, you all know multiplication, first row first column, second row first column, third row first column, and compare with this -1 -x -y -z. So we now have 3 equation and 3 unknown. After solving we can we get the value of x, y and z. So here if we bringing all the left side, so this is become 3x is equal to 0, 5y plus 5z is equal to 0 and 4y plus 4z is equal to 0. So we can say that x is equal to 0. Okay, now here you can see that y is equal to -z. Okay, yes, 5 cancel out and y is equal to -z. So you can write any value as a y, 1, 2, 3 and it will change with the -z. So this is a this is one vector we have infinite. Always you have to remember that for one eigenvalue we have the infinite number of eigenvector. Why? Because last lecture I have told that if Ax is equal to 0, then this system has a infinite number of solution. So x is a infinite number of vector for the one eigenvalue. So you can say that 0 1 1 1 0 2 minus 2, also you can say 0 no, minus 2 and 2 also. Okay, condition is x is equal to 0 and y is equal to minus z. Okay, so this is our first eigenvector. Now let's say this is true or not. Let's start. So let's say if we multiply matrix with the column vector 2 0 0 0 1 minus 1 and find out column matrix multiplication, so we get 0 minus 1 1 and find out lambda v, so also we can get the same answer. Okay, so this is a eigenvalue and eigenvector. Okay, you can also solve eigenvalue with respect to 2 and eigenvector with respect to 2 eigenvalue, and also eigenvector with respect to 8 eigenvalue. Okay, so for this matrix has a 3 eigenvalue and its related eigenvector, number of eigen infinity vector. So this is a 3 by 3 matrix. Now let's say different types of example rotation. Okay, so how do we rotate? Okay, you can say that this is a vector. Yes, eigenvector is a ax is equal to ix. Here you can see that here vector vector has remained same. So for the definition we can say that if we multiply with vector as with the matrix and any scalar number, its direction is remain same. Okay, yes, and now how do we find x? X is a which vector, if we change rotation with the vector, then its direction will remain same. Let's say like this example, if this is f green, this is f, okay, in graph. Now if we rotate all the point, okay, so which direction that doesn't change with the direction rotation. Okay, so you can see that this direction is not changed with the rotation point. Okay, so we have now changed the rotation of f, so you can see that this y direction is not changed with the direction. So with the mathematical we have now vector eigenvector is this vector. Okay, this direction in short eigenvector is if we rotate all the point, its vector's direction does not change with the rotation. Okay, it's remains same. Eigenvector is a remain same if we change the rotation. Okay, so now let's say this is this is matrix cos theta, sin theta, minus sin theta and cos theta. If we want to change this matrix by 30 degree, so what is the vector that does not change with the this rotation 30 degree rotation? We have to find this vector. So if we want if we find eigenvector, then we can say that with this matrix, if we change it with the 30 degree, then this vector is does not change its direction. Okay, vector does not change the direction. So let's say here theta is equal to 30, cos 30 is equal to root 3 by 2, sin 30 is equal to 1 by 2. sorry. Sin 30 is equal to 1 by 2. Okay, so we have now this matrix. Now we have to find eigenvalue and eigenvector for this matrix. This is simple. We all know how to find eigenvalue and eigenvector for 2 by 2 matrix. Okay, let's start. First of all, we calculate a minus lambda I. Here a minus lambda I. So we have now a minus lambda I. Now we will make determinant should be 0. This matrix determinant should be 0. Okay, so determinant of 2 by 2 matrix is easy. Multiplication of diagonal value minus multiplication of other diagonal value. So this is 0. So it's become quadratic equation. Okay, lambda square minus, if we solve this equation, this will become coordinate equation, lambda square minus root 3 lambda plus 1. Now here if we want to find about this quadratic equation, its roots will become imaginary solution. Why? If we want to find out this with the minus b plus or minus b square minus 4ac. Okay, if we calculate b square minus, what is b square? Root 3 means root 3 means 3 minus 4 and ac 1. Okay, so we have now under root minus 1. Okay, this under root will minus 1. You all know how to find about this root equation. Okay, so we, if it is under root in negative under root, so we have root as a complex number. Okay, so they have calculated direct complex number. So don't confuse, this is some difficult example. Okay, it's just for your information. Okay, in exam this types of difficult question do not ask in exam. Okay, so this root have imaginary value, complex number. Why? Because under root is a negative value. Okay, so this eigenvalue are complex. Now we have two eigenvalue, one is plus and one is minus I by 2. So now we have to find out this in eigenvector. So this is equation av is equal to delta v. We will put value of delta, this is a, b as xy and delta. Okay, now multiplying with these two matrix, we have now this equation, and after solve with the calculation, we have now minus y is equal to ix, means x is equal to iy. Okay, so now we have infinite number of solution which include x is equal to iy, like we can say 1 and I also. Okay, also with this example minus y and ix, we can also take minus I and 1 also. Okay, and 2i. Okay, so this is our eigenvector. Okay, with the rotation of. Okay, so what will we have now answer if we rotation with 30 degree of this matrix cos theta minus sin theta and cos theta, this vector will remain as it is. This does not change with the rotation of 30 degree. Okay, so this is a eigenvector. Okay, now let's say start with another example. Find the eigenvalue and eigenvector of this matrix. This is 3 by 3 matrix. Okay, first of all, let's start a minus lambda I. Okay, so this is a minus lambda I, and this determinant will have to become 0. So we have to solve. So now here you can see that here this column has a 2 0. So we will if we want to find determinant of this matrix, we can say we try with this column. Okay, so first will become 0, only we have now this value minus 2 minus delta, and if we include this row and column, we have 2 by 2 matrix as 7 minus lambda minus 3 18 and minus 8 minus lambda. If we solve this determinant of 2 by 2 matrix, we have now this equation after solve the with the calculation. Okay, so now we have this we have to become 0, so we have now root is equal to lambda 1 is equal to minus 2 and 1 is a 1. Okay, let's start with the 1, and now we have to find out about the eigenvector. Okay, so how do we calculate a minus I x? We will put this equation ax is equal to lambda x. Okay, we will put 1 and multiply with the A matrix. So we have now after calculation we have x3 is equal to 2x1 and x3 is equal x2 is equal to x3 minus 3x1 and x2 is equal to minus x1. So we can here this is x3 is equal to 2x1 and x2 is equal to minus x1. If we take first vector, so we can say that if we take x1 is equal to 1, so x2 will become minus 2, minus 1, and x3 will become 2. So this is the scalar multiplication of eigenvector and multiply with the other value. This is eigenvector is always minus 2 and 4 also. This is also eigenvector. Okay, so you get the better idea. So how to find eigenvalue and eigenvector. Also they have solution with the also other value like this minus 2, and they have applied direct answer x3 is equal to 3x1. Okay, so this is the eigenvalue and eigenvector for the 3 by 3 matrix. Okay, so now your all the vector and matrix chapter is completed. Okay, in next lecture we will start with a new chapter, either power series or function. Okay, so here your all the vector and matrix chapter and all the topic are covered and completed. Okay, this is your today's assignment question. You have to find eigenvalue and eigenvector of this 3 by 3 matrix and upload it in red and white application. Okay, so today's now your today's lecture is completed.